Good morning, everybody. So today we are looking at lesson 12.9 in math, and this is going to be our problem solving lesson on elapsed time. So let's get started. It says our essential question here is how can we use the strategy draw a diagram to solve elapsed time problems? So get ready to do some drawing. All right, unlock the problem. Dora and her brother Kyle spent 1 hour and 35 minutes doing yard work. Then they stopped for lunch at 1:20. At what time did they start doing yard work? Use the graphic organizer to help you solve the problem. And so you get this nice organizer down here. And let's see, I'm going to try to get even question 1 in this first second sketch. All right, so what do we need to solve the problem? I need to find the time that Dora and Kyle started work. I need to use the blank and the time they blank. So I don't have all the questions, but they worked. You need to use something along the lines of the total time they worked and the time they ended. The time they ended work. So if I know how long they worked and I know when they ended their work, then I can figure out when they started working. I can draw a timeline to help me count backward and find the start time. Alright, and now we're down to solve the problem. I drew a timeline that shows the end time 1:20 p.m. Next, I count backward 1 hour and then 5 minutes at a time until I have 35 minutes. Alright, so Dora and her brother Kyle started doing yard work at, and according to our chart here, if we watch how they counted, so they said 1:20, an hour earlier would have been 12:20. I need 35 more minutes. So they did 5, 10, 15, 20, 25, 30, 35. And if I was looking at a clock, each of those bumps would have taken me back 5 minutes until I have a start time of 11:45 a.m. Doesn't seem to be too bad. What if Dora and Kyle spent 50 minutes doing yard work and they stopped for lunch at 12:30? What time would they have started doing yard work? Now, I'm not going to get rid of their nicely drawn graph here. I'm just going to repurpose it for a second. So I'm going to switch to a bolder color, and then we're going to look at this. So in question 1, what if Dora and Kyle spent 50 minutes doing yard work and they stopped for lunch at 12:30? So here's the new lunch time because I don't want to have to draw a new graph, and this one is perfectly fine. And they only worked 50 minutes. Well, one thing here is you have to realize they're only counting by fives. You gotta be careful. So let me make sure it's correct. So 12, 12, 5, 12, 10, 12, 15, 12, 20. This is correct as far as the tick marks go. So I'm going to count back by fives. So let's see, 5, 10, 15, 20, 25, 30, 35, 40, 45. I need one more back here. So you can figure that out. You just need one more bounce to get to 11:40 a.m. They started work at 11:40 a.m. in question number 1. That's about it. It can get a little tricky sometimes. You got to pay attention that there's 60 minutes in an hour, 60 seconds in a minute, 12 hours or 24 hours in a day, things like that. All right, let's keep moving here. Try another problem. Ben started riding his bike at 10:05 a.m. He stopped 23 minutes later when his friend Robbie asked him to play kickball. At what time did Ben stop riding his bike? So seriously, the only parts of this question that you need are the start time and how long he was riding his bike. It's great that he went playing with his friend, but in terms of math, it's totally unimportant. So I need to find when he stopped. And what information do I need? I need to use the start time and how long he rode his bike. And what am I going to do? I'm basically going to add 23 minutes to 10:05. Now they want a number line, which they've very nicely included here. So I'm going to take our number line, and that's where I'm going to pick up at here. So 10:05 and 23 minutes. Okay. I'm going to focus on solving the problem here in question 2. You guys can work on the top a little bit more yourself. All right. So if he started at 10:05 and he rode his bike for 23 minutes. Now let's see, 6, 7, 8, 9, 10. Okay, the tick marks on this are 1-minute intervals. Excuse me. So I'm going to count 5 minutes, 10 minutes, 15 minutes, 20 minutes, 21, 22, 23. And that means he stopped at, this is 25, 26, 27, 28. He stopped at 10:28. And if you think about it, if I just took the minutes that they were writing, it was 10:05, so 5 plus 23 is 28. This was a fairly simple question. How did your diagram help you solve the problem in question 2? Well, it's a good visual way to see the time that has progressed. So, yeah, it helps. Addition helps too. Okay, math talk. Describe another way you could find the time an activity started or an activity elapsed. Time in either the start time or the end time. So basically here, we're talking adding and subtracting. Now, this problem was easy because we didn't cross over a full hour. Um, the problem with adding and subtracting with time is that we're so used to numbers that, you have to go 1 to 9 until you get a new place value and borrowing and adding and carryover and all those things that come with just regular adding and subtracting. It's a little bit different with time because time uses 60 minutes in an hour and 60 seconds in a minute, and those things can start to give you some problems when it comes to elapsed time. So, like I said, this one wasn't too bad. All right, moving on. Actually, this is the work problem, so I'm going to start a new video for this section. All right, hope to see you guys soon. Bye-bye.